solve the differential equation. So we have this equation and it says x is positive. Okay, makes sense because natural log of x. Due to this plus y, we cannot separate the variables, so this is not separable. Okay, so let's try to see if it is linear. Yes, this is a linear ODE because dy, derivative of y and y. Now we need to write in a standard form, means we need to divide by this x. Let's divide by x, then we have dy over dx 1 over xy, and we can divide by x because x is not 0, it's positive. Divide by x, so 4 copies left. Now this is in the standard form of linear, and we know that when we have dy over dx plus equals some function, then to make this exact, we find an integrating factor. Integrating factor is just e raised to integral of this function px with respect to x. And once we find this integrating factor, we multiply through by this, and this left hand side becomes just an exact, or this one automatically becomes derivative of the dependent variable, which is y, times the integrating factor. Okay, the integrating factor, whatever we have, that will be always automatic, so you can check if you like. So here integrating factor is e raised to 1 over x dx. So antiderivative of 1 over x is just natural log of x, and we don't need absolute value because x is positive. Now e and natural log, their actions cancel, just x. Multiply this ODE by x. Okay, let me say star, by this integrating factor. Okay, the left hand side always becomes derivative of dependent variable, which is y, times x. In fact, if you multiply through, let me show you what happens here. This should have been x dy over dx plus, when we multiply by x, cancel just y, and this one is just the derivative of y times x. If we find the derivative of this product using the product rule, then we exactly get this. Okay, so that's the case. In anyways, in the left hand side we have derivative of always dependent variable times the integrating factor is equal to, we are multiplying this by x, so this becomes x to the 5th ln x. Now we integrate both sides with respect to x. Okay, so let me go a little bit below here. Integrate with respect to x, then this one is just y times x, and the right hand side we have x to the 5th times ln x dx. Now we need to integrate this, and we got a product, so integration by parts. As we know, when we have u times dv, that is uv times minus integral v du. Okay, so in this case, let u be always ln x or x over 5. So which one? You need to decide on that from calculus 2. And we know that from calculus 2, whenever there is natural log, that becomes u. For obvious reason, when we choose u, we should be able to u is the function when we can differentiate but difficult to integrate. Okay, if we take dv equals natural log of x, then antiderivative is not easy. Okay, but x to the fifth, yeah, we can find easily antiderivative, so u is natural log of x. Then du is just 1 over x dx. Take antiderivative, so that's the x 6 over 6. Okay, then we have y times x in the left hand side, integrating by parts here, uv, so this one times this, minus integral v du, v du, x 6 ln x, minus 1 over 6 we can pull outside. Now 1 copy cancels, so 5 copies left. So basically we are left with x raised to 5, and we know how to integrate this. Okay, so we get x 6 over 6 because x raised to 5 and plus some constant of integration, and this is it. Okay, almost. Now we need to isolate y, sorry. So we divide both sides by x. So y as a function of x is equal to divide by x. So 1 over 6 x, 5 copies ln x, minus this is 1 over 36. Yeah, we are dividing by x, so x raised to 5, plus we are dividing by x, so c over x final.